Okay, welcome back. We are still busy with solving a linear programming problem on the graphical way in a two-dimensional space. In the previous lecture, we looked at the level line method. In this lecture, we are going to start looking at the corner point method. Now, the corner point method, the first part is very similar to the level line method, in the sense that we first need to identify the feasible region by plotting the feasible region on a graph. Now the difference is that we need not plot the level lines. Once we have the feasible region, we will identify the corner points of my feasible region and then evaluate the objective function at each of these corner points, because we know from the remark from the previous lecture that the solution to my LP problem will be at one of the corner points. And then the solution which satisfies the optimization criteria, whether it's to maximize or to minimize, will then be my optimal solution. So to illustrate this method, we are going to look at example 53. This example is again in the classical form of an LP problem. We have the objective function, and then we have our three constraints and also the non-negativity constraint. So we start by plotting our feasible region. I'm going to go through this whole process again of plotting your feasible region, just as some extra revision on feasible region. Okay, so let's look at our first constraint, 10x1 plus 8x2 less than or equal to 800. Okay, so first of all, we will start by setting x1 equal to 0. So if we set x1 equal to 0, we can solve for x2. This part will be 0, so 8x2 is equal to 800, so x2 must be equal to 100. So my first point on the graph will be the point 0, 100. And then we set x2 equal to 0. So this part will fall away. 10x1 is equal to 800. So that means that x1 will be equal to 80. So my second point on my graph will be the point 80, 0. So we can draw this first constraint on our graph. This is my first constraint. To know whether the constraint lies below the equation or above the line, we choose any arbitrary point. Let's just choose the point, let's take the point 10, 10. If we take the point 10, 10, we substitute it into this constraint. So we have 10 times 10 plus 8 times 10. So that's 100 plus 80. That's 180, which is definitely less than 800. So the point 10, 10 satisfies this inequality. Which means that all the points on the same side of the line will also satisfy this inequality. So we know that this inequality implies this area below the line. Okay, then if we look at the second constraint, 3x1 plus 4x2 less than or equal to 360. So we start by setting x1 equal to 0. This part will fall away. For x2 equal to 360, which means that x2 must be equal to 90. So the point on the graph that we will use will be the point 0, 90. And then if we set x2 equal to 0, this will be 0, so 3x1 is equal to 360, so x1 will be equal to 120. So the second point will be the point 120, 0. So we can plot this now on our graph. And this is now constraint 2. Again, you can check whether it's below or above the line. You can go and check that. In this case, it's also below the line. Okay, and then the third constraint, x2 greater than or equal to 60. Now that's easy to draw. X2 equal to 60 is over here. Greater than or equal to 60 will be everything above this line. Okay, and that's constraint 3. So now to find the feasible region will be the area where all these lines intersect, where the green, the red, and the blue lines intersect. Okay, of course, for the non-negativity, we know that x1 cannot be negative, x2 cannot be negative, and then we take out everything where we don't have the three colors intersecting. So we take out all of this. Okay, and there you have your feasible region. You also have a neater version of that in your notes. So you will see for this feasible region we have 4 corner points. We will call them A, B, C, and D. You can call them whatever you want to, in whatever order you would like to call them. In the next lecture, we will now find the values for x1 and x2 at these 4 corner points, and then evaluate the object, the function at the 4 corner points.